All right, so let's go ahead and review plane mirror. Go ahead and draw a plane mirror and the object sitting out there, and see if you can remember how to draw the ray diagram for a plane mirror. So go ahead and pause the clip and give this a try. When you're ready to check, you can hit play to continue. All right, so if you remember, if you go straight from the tip of the object straight out, and it'll reflect straight back. The other one, you hit towards the normal line where the bottom of the object is. It'll reflect that way, and we see the rays are diverging. Therefore, we trace them backwards, and when we do that, the object, or the image rather, is on the other side. And we talked about how, let's say you're 5, or let's say you're a meter from the mirror, right? Turns out your image is a meter from the mirror, so the total length there would be 2 meters away. The name of the image, virtual, upright, and true. So it's virtual, it's on the dark side, it's negative side, it's upright, and it's true. All right, so let's go ahead and practice this one here and see if you can draw the ray diagram for this one. So go ahead and pause the clip and give this one a try. When you're ready to check, you can hit play to continue. All right, so here's a parallel ray through the focus, focal ray. The object should be here. So the object would be real, it's on the positive side. The object is inverted and it is enlarged. Okay, yeah, why don't you go ahead and try this one here. This is where the object is over the focal, or over the focus. So go ahead and pause the clip and give us a try, and when you're ready to check, you can hit play. All right, so we have a parallel ray, center ray, and no image is formed at the focus. So if you remember in that lab where you were walking towards the concave mirror, there was a point at which, there's no focus, or no image at the focus. It's all blurry. All right, so let's go ahead and practice this one here. This is going to be a convex mirror, and objects is located out here. And so yeah, go ahead and draw this one. The focus is located at -4. The object is located at 23 centimeters away, and the height is 6 centimeters, and we want to find where's the image distance and what is the height of the image. So yeah, go ahead and pause the clip and give this a try. Draw it first and then calculate and then name your image. And when you're ready to check, you can hit play to continue. Okay, so our rays here that we draw, we can draw the principal ray, goes out, focal ray, center ray goes straight out, and then we trace them backwards, and it's located somewhere back here, pretty small. We should get for DI 3.41 centimeters, for magnification 0.148, and a height of 0.88 centimeters. All right, so now we're ready to look at thin lenses, and the first one that we're going to look at will help with what's called farsightedness or hyperopia. This is where we're looking at an object, and in a person that has hyperopia or farsightedness, the image can't form on the back of the retina. So what will happen is we can get a lens that's convex lens, that's wider in the middle, and it'll cause the rays to start to bend inward. Therefore, the rays will end up where they need to be on the retina, and you can make out what an image is. So distance objects are more clear, closer objects are blurry, and so the kind of lens we need is the convex. Now, you don't have to remember farsightedness, hyperopia, but it's good to see this application here, so one of the critical applications of this for eyesight and corrective vision. So converging lenses are also called convex. You need to remember both terms. And converging is talking about what it's doing. If you have rays that are coming in parallel, they're going to converge and then end up being the focal point. Now, one of the most critical things probably this whole lesson is the positive side is where the refracted rays go. The light is coming from the left, going through the lens to the other side. And as it goes through, we end up with the focal length as being positive on the right-hand side. And so that is a really critical thing that you want to get down. And again, the positive side is where the refracted rays go, because the light goes through a lens. It doesn't bounce like a mirror. It bounces backwards. And so this is a major difference here. So all of these parallel rays will come and refract here and then refract here. And the rays will then, all converge here. And it's convex because it's larger in the middle. It's converging, right? The other name, because it's all converging there to the focus.